Hey, it's Rob. I'm going to show you how to do the one sample or single sample t-test on SPSS. So on our left we have the data set that we're going to be working with that doesn't have anything in it now. And on the right side we have the output, that's where all the information is going to go. So first, let's just go down to variable view and create this fake variable. Let's say it's IQ. So we'll name it there. I'll scroll to the right a little bit and I'll make this a scale measure. So just for the sake of demonstration, I'm going to make up a few values. 102, 105, nope, I want to say 105, 107, and then 104. Okay, so we have 7 values here and equals 7. That would mean that we have 6 degrees of freedom. So the way we're going to do this is we want to compare the mean of this sample to a known population value, which let's just say in this case is the population mean equaling 100. So the way we're going to do this is we're going to head up to Analyze on the top here, and then we're going to go down to Compare Means. And then, as you probably guessed, we're going to do one sample t-test. We'll click on that. So you're going to pop up with this screen here. We've got our only variable here right now. So what we want to do is move IQ into the test variables. So again, it's going to be over here. We want to move it over to test variables. If you click on options, just click on that and make sure that we have a 95% confidence interval. It should have that by default. Okay, so here's the important part, and this is something that I always forget. The test value, you need to change this to the population mean that you are comparing your sample against, or it's going to be mu in whatever case. So in this case, I said that the population mean that we're comparing our sample against is 100. So this is the value that our sample is going to be compared to. And remember, for a one sample t-test, we don't know the true population standard deviation, so we don't need to enter that here. All we need is this data, and we need this test value, which is the population mean. We're going to go ahead and hit OK, and over on the right side you see that we get our sample information for IQ, n equals 7, as we know. Looks like our sample mean is 101.8586. Our sample standard deviation is 3.72, and then it gives us the standard error on the right side. So this is where on the bottom here, this bottom square, the one where the arrow is right now, it's labeled one sample test. This is where it actually runs the test. So right here, you're going to see the t value. The t value here is 1.322, and then it shows us our degrees of freedom, which you'll notice is also just n-1. Then this is the most important number. On a two-tailed test, it's going to show us the significance. This is actually our p-value. Under sig two-tailed, this is our p-value. So our p-value in this case is 0.234. P equals 0.234 in this particular case. So if we're using a p-value of 0.05 as our cutoff point, then you'll notice that 0.234 does not exceed that. It is not lower than 0.05. So we will fail to reject the null in this case that our sample is different from the population mean. We will fail to reject the null, and our research hypothesis will not be supported. And then I should have shown you how to write that in class. So there you are. Let me know if you have any questions.